So in this video we're going to look at how we derive the equation of a straight line. Much of this material is going to be reviewed from stuff that you've learned in Algebra 1, Algebra 2, even pre-algebra. But we're going to come at it from a more of a geometric point of view rather than an algebraic point of view. In the sense that in algebra you start with equations and then you plot points and you say, oh hey, look, if I plot points on this, the graph of this ends up being a straight line. In geometry we're going to come from the opposite point of view. We're going to start with the line and we're going to figure out, okay, what is an equation of this line going to be? So we're starting with the picture, with the geometry, rather than starting with the formula. In either case, starting with the algebra or starting with the geometry, one of the critical ideas for understanding the equation of a line is understanding what's meant by the slope of a line. So I've got a couple of lines here, and I want to draw some stair-step looking triangles on this blue line. I'll draw that one there, and let me draw this one here. There we go. Following the coordinate grid that is superimposed on these lines. So these lines are vertical, and so they are parallel. These lines are horizontal, and so they are parallel. It also means that this is a right angle, as is this. And using ideas from first semester, this angle here corresponds with this angle, which means that these two triangles here have to be similar. These are similar triangles. Because of the parallel lines here, these are what are called corresponding angles. We call them F angles. So that means that ratio of two sides here is the same as the ratio of two sides here. And this ratio is what we call the slope of the line. Let me be more specific here. When you move from one point to another on a line, your y-coordinate will change because you have to move up or down. Your x-coordinate will change because you have to move left or right. This change in the y-coordinate is written delta y. Delta is a symbol that means change in. This is not a multiplication. This is not delta times y. This just means change in y. It represents a single number. And here, since we're moving down 2, the change in y is minus 2. And then, as I moved here and then over to there, I'm moving to the right 6 units. So I would say my change in x, since it's to the right, is plus 6. Of course, you don't need to write the plus, but when I'm writing changes, I like to write the pluses and the minuses to emphasize if it's a change in the positive direction or a change in the negative direction. And the ratio of these, minus 2 over 6, which of course reduces to 1/3, or minus 1/3 rather, is what's known as the slope of the line. And the whole point with observing these similar triangles is just to note that if I go someplace else on the line and make these changes, the ratio is always going to be the same ratio. Change in y over change in x is always going to be the same number for a given line. And this number is called the slope of the line. And we use the letter m to represent the slope of the line. And the way it is computed is you do the change in y over the change in x as you move from one point on the line to another point. A couple of quick notes on slope, and then I want you to do some practice problems before we continue. Okay, one is if I had made my motion sort of in the opposite direction. So let's say I went like this and then like so. Remember, when you're doing computing slope on a line, you move from one point on the line to another point on the line, and you look at how y changes and how x changes. Now my change in y is positive. It's plus 3 because I moved up 3. But my change in x is going to be negative. I went to the left 9. And so the ratio, positive over negative, is going to be still a negative number. You're always going to get the same ratio. Here it's going to be minus 1/3. The other thing I wanted to point out, so the first thing was, it doesn't matter if I go here to there, or if I go the other direction, that way. in choosing how I'm making my motion. Like if I were to reverse this motion here, the change in x and the change in y would both change sign, but the ratio would still be a negative number because they would be different signs. This would be delta x would become -3, delta y would become +1. So we would have +1 over -3. It's always change in y divided by change in x. The second thing is that you can tell just by looking at a line whether it has a positive or a negative slope. Lines that slope downwards as you move left to right, like you're reading the line on a page, are going to have negative slope. And lines that slope upward as you're moving across the page from left to right, that move upward, are lines with positive slope. This will have a positive slope because if I make a motion from one point to another on the line, the changes will have the same sign. This is going to be a change in x of +3 because it's to the right 3. This will be a change in y of +4. So this line slope is +3 over +4, or 3/4. Positive slope because it's moving up. So on your handout that goes with this lesson, which looks like this, if you haven't gotten this handout, then you should get one now, because this video is intended to be done along with this handout. I would like you to try to do these 4 problems now. Pause the video before you continue, and then I will go over them. Alright, so hoping you've tried these 4 problems, let's do them quickly. So 0, 4 is here, 5 just off the graph, -2 is there. So I'm going to sketch the line. It looks like this. It's going to continue forever. And I'm going to determine the slope of the line. So I have going to move like this from that point to that point. Change in y is down 1, 2, 3, 4, 5, 6, -6. Change in x, 1, 2, 3, 4, 5. That's a change of +5. So the slope of this line, change in y over change in x, is -6 over 5. And I always, when I write a slope for my final answer, I always write with the, if it's negative, with the minus on the fraction bar. One thing I want you to note is there's a shortcut for computing these changes where you can just use the coordinates. If I'm going to move from a start point to an end point, the change is going to be my end coordinate minus my start coordinate. Like, here's my start point, 0, 4. Here's my end point, 5 minus 2. So if I look at my change in y, I take the end coordinate and I subtract the starting coordinate, and that tells me what the change was. -2 minus 4, end coordinate minus start y coordinate, that's my -6. And then 5 minus 0, that's my change in x, 5. And this is something that you understand if you think about it. If I want to know how much do I change in going from 1 to 4, if I think, okay, here's 1 and 4, my change in going from 1 to 4 is 3, positive 3. That's why I have to do end minus start, 4 minus 1. So if I want to compute a change, I can do the end coordinate minus the start coordinate. That's going to be important, what's going to follow down below here. Let's finish up these ones. So I want to sketch the line and determine the slope. Here's the point 1, 3. Here's the point 3, 1. This is sloping downward. Change in y is -2. Change in x is +2. So the slope is the ratio of those changes, -2 over 2, which reduces to -1. Next one. These two I made a little different, and we're going to come back and hit on these topics in the next lesson. Minus 4 plus 2 is right there. Plus 3 plus 2 is right here. So this is a horizontal line. There's no change in y here. This line is perfectly horizontal. It doesn't go up or down. So the change in y going from here to here is 0. The change in x is 7, but it doesn't matter. Whatever the change in x is, because if I put a 0 on the top of the fraction, 0 divided by any number is 0. So this is the slope of a horizontal line. Is always going to be 0. Horizontal lines are neither going up nor going down. They're horizontal, and so they have slope 0. This is an even more peculiar case. I have minus 3, 1. I have minus 3, minus 2. So this is a vertical line. And in moving from one point to this point, the change in x is 0. Because it's going straight up and down, x is not changing. You can see that here. The x coordinate stays the same in both cases. So this is a bad thing in terms of computing slope. Because now I get my change in y here is minus 3, but it doesn't matter. Because I have a 0 in the bottom of the fraction. And you're not allowed to divide by 0. So we say vertical line has undefined slope. Please do not say it has no slope. Technically that's correct, but no very easily in your mind might turn into 0. Horizontal line does have a slope. The slope is equal to the value 0. Vertical line does not have a slope, so we're going to say it has undefined slope. We don't want to slip into thinking that the slope of a vertical line is 0. It's not. Vertical line, undefined slope. Horizontal line, 0 slope. In the next lesson, we'll come back and look at these special cases for equations of lines. So to complete this lesson, we're going to derive the equation of a line. And it's not going to be the most familiar that you remember from Algebra 1, Algebra 2, because we're coming at it from a geometric point of view. However, it is going to be something that you've seen before. And remember what I said at the beginning of the video, that we're going to begin with the line, and we're going to figure out what the equation has to be. So here we're going to figure out what the equation of a line is with slope m, and that passes through the origin, so it passes through 0, 0. Then we'll do the general case below, where it has slope m and it passes through any point whatsoever. Let's focus on this case right now. So we're going to figure out the equation of this line. We know it has slope m. Remember, we usually use the variable m to represent the slope of a line. And we know that it passes through the origin. So xy here is going to be some point that happens to be on the line. xy. Because it's on the line, and because 0, 0 is on the line, I can do a little slope step, like this. So what's my change in x, going from here to here? Well, remember, what I said up here is that you can get a change by doing the end coordinate minus the starting coordinate. So if I look at my end coordinate for change in x, I end at this value x, whatever it is, and I began at 0. So my change in x is x minus 0, which of course is just x. Likewise, my change in y, end coordinate minus start coordinate, is y minus 0, so that's y. So when I write down my slope, remember slope is change in y over change in x. My change in y and my change in x are y and x. And then I'm going to multiply this x out of the bottom of this fraction because I don't want it down there in the bottom. And I'll get a y all by itself on one side equals m times x. So that is an equation of this line. If x and y are on this line, x and y have to satisfy this formula. Now, I want to make this more general now, and this will end this lesson. What if it doesn't pass through the origin? What if it instead passes through some other point? There's a possible source of confusion here. x0 and y0 is going to be the specific coordinates of a point that we know is on the line. And xy are going to end up being our variables in the equation that we get at the end. It's potentially confusing, but when we do an example in the next video, hopefully it will become clear what's going on here. So let's do what we did here for this line. We know it has slope m, and I'm going to make this stair step that's going to start here and end here. So, following the idea of end coordinate minus start coordinate to get changes, my change in x is end coordinate x minus start coordinate x sub 0. Remember, when you put a subscript on a variable, it can represent a different value of this. These could very well be different numbers. The reason we use x sub 0 is because we don't want to lose the fact that this is an x coordinate. It's just a different x coordinate from that. Likewise, change in y is my ending y coordinate minus my starting y coordinate. So that's y minus y sub 0. I know this line has slope m, whatever m happens to be. So if I say m is change in y over change in x, then I will copy these changes y minus y0 for delta y, x minus x0 for delta x. Then I don't want to have fractions in my final answer, so I'm going to multiply by this denominator. Those divide away, and I'm going to write this side first. So I'm going to have y minus y sub 0 equals m times x minus x sub 0. And this is what is known as point slope form for a line. It's called point slope because m is the slope and x sub 0, y sub 0 represent the coordinates of a point on the line. And that's worth making a note here, and then we will end this video and we'll do some examples. So slope is m, x0, y0 are coordinates of a point on the line, and x, y are going to be my variables. They will remain as variables in my equation. In the next video, we'll do some practice problems where we work with this and some other forms for a line.